Hey guys, this is lesson 24, and what I did is I printed out page 10 of chapter 24, and it's been helping. And I also, throughout the chapter, there's some different Fisher projections like fructose, there's like mannitol and glucatol. I printed those out, but the most important one was basically fructose. And then I just looked up some disaccharides. I believe the only ones for sucrose, lactose, and maltose. So I have those in front of me. It's a little easier. So we'll be going through this. I haven't seen his videos for any of these. I'm just kind of basing it off of lecture. So let's get started. Okay, so we got a small one. Okay, so I'm gonna turn it around this way. I think. No, this way. I believe this is gonna be. I hate these. 1, 2, 3, 4. So I have 4 oxygens. So I'm going to look at either erythros or threose. And okay, so I'm going to I don't know if this is D or L, to be completely honest. Either way, these are on the same side, so I'm thinking it's erythros. I just don't know if it's D or L. Let me see if I have an example in my book. So yes, I think it is erythros. If we look, so we see that this is up, so this is going to be beta. I don't know if I said alpha earlier, but it's going to be beta. And then D. And then we're going to go down and do the code. So I see this is facing down, so this is going to be on the right side. And then this is also facing down, so it's going to be on the right side. So we're going to put erythrofuranose. Erythrofuranose. Okay, and I'll show on another example what I mean by right, down, because these are facing down, but I want a better example. Okay, I think it's spelled right. It is beta. This is beta because it's facing up. All right, let's check it out. Okay. Okay. I'm guessing this is threose. So this one is face down, so it would be alpha. And then we jump to this one, and it's faced up. Let me see if I can get. Okay, so this is D because we see our highest priority is up here. And then over here, let me see. You got one, you got one, you got another one, and okay. So 1, 2, 3. It looks like S, but it's R. So that's why it's D. Same for the other one. Sorry, I just woke up. Okay, so then we go to our code. I'll just go ahead and do a little example of what I mean. So when I'm comparing to the Fisher projection. So we have our CHO at the top, that's the carbonyl, and then we have our threose, and then it's like this, and then we have like all this other stuff. So when I say So we disregard this one. This is just an indicator of if it's alpha or beta. So we jump to this one. And then we're only focusing on these two in the middle, which is why we have 2 here. So this is faced up, so it should be on the left. This is face down, so it should be on the right, which makes sense because it coordinates to 3 O's. So 3O, fear, and nose. Okay, let me make sure I spelled it right. 3O, fear, and nose. Okay, I hope that's right. I'm a little tired. Awesome. Okay. So these, I like to take them step by step. What we're going to do is turn the hydrogens off first, and then we're going to look at the point that it's connected. So I see that, let's see. I see I have a methoxy group up here. So this molecule needs to be turned to the left and it's attached at the 1 position. So this is going to be my second molecule that I evaluate. I see this one has everything where it's supposed to be. I have my methoxy group up here. So this is the one I'm going to be looking at first because this is the way we want our molecule. So if we only had 1 molecule, this is how it would look without any of this. It would have this oxygen, it would have this methoxy group on the left where we would orient it to the left, so this would be there. It would have just oxygens here connected to these carbons, that's it. So this is why we look at this one. This one is the second one, we know that because our methoxy group is on the left where we want it, but we see it's connected here. So that's why this one is being connected to this one. So I'm gonna go one by one. And I also noticed that there's 6 member rings. So this is either gonna be, let me get my disaccharide, lactose, or maltose. All right, now I'm gonna turn on my hydrogens and start evaluating them. So I see this is at the beta position, so I'm going to put beta. And then I also see that my methoxy group, so I found a little trick. When you have the methoxy groups on top, only methoxy groups. So if you have 2 carbons with 2 oxygens, this doesn't apply to that. This is strictly just for the methoxy groups. I want to stress that. When you have the methoxy groups on top, right, relative to the hydrogen, it's going to be D. So these are both D, it looks like. Okay, now I'm going to start reading the code. And it helps if you have a little notebook or a paper and you can just write, or you can just draw something like what we did here, and you can just draw the code and then match it up. So if I was drawing the code, I would be like, I would say right, okay, sorry, down, so I would do it on the right, up, so I would do it on the left, down, so I would do it on the right, and then this is our configuration, so I'm going to do it on the right. So this is what I would get on a scratch sheet of paper. I wanted to show you guys. I'm not going to do that for all of them. This is the only one I'm going to do it on, just to show you guys like how to do it. So that was right, left, right, right. That's glucose. So I'm going to put glucopyranose. I'm going to jump to the front and look at where it's connected. So I'm going to count from here, 1, 2, 3, 4, 4-O. Not 0, O. Okay, and then I think we've established, okay, so this is alpha because it's facing down. So I'm gonna put alpha dash, and then my methoxy group is facing up. So I'm gonna do D dash, let me put my parentheses already. Okay, so I've got down, so it's right, left, up, right, right. So this is also glucose. So I'm going to put oops, still. and then I'll put a dash after those parentheses. 4-O, and then I have some like little examples of names that I wrote down. They're not exactly the same names, but it helps kind of make sure that I have every component here. So like some of them have beta, but I know that this is like the alternative. Make sure I have all the dashes necessary and that I put this the right way, like the pyranosyl. Beta D glucopyranose. Let's try it out. Okay. And I really like to do this big name. I don't like to do the common name. I'm just not good at that. So yeah. Okay, so let me get my galactose, and I say it's pyranose, so I'm going to do a 6-member ring. The pyranose is actually much easier to do than the furanose. So let's try it out. Okay, so we see that it is beta, so that means on this right carbon, we're going to have oxygen on top, and then it's going to be D, but we'll get to that at the end. Okay, so I look for my galactose and I read the code. It's the first one's right after the CHO, so I'm gonna put it on the bottom. The second one is left, I'll put it on top. The second one is left, I'll put it on top. And the last one is right, so I want to do the R configuration. For this one, it works out perfectly because I end up with a methoxy group. But some of them you end up with the 2 carbons, and that's where it gets really tricky. Okay, so now I want to count my carbons and my oxygens. So I have 1, 2, 3, 4, 5, 6, and I should have 6 carbons too. 1, 2, 3, 4, 5, 6. Okay, and then this indicates it's D because I have it on top relative to the hydrogen, that methoxy group. So just to double check, I have beta on top, and then I have right, left, right. Ooh, wait, did I put that on top? Yeah, wait. Okay, right, left, left, right, okay. So down, up, up, right for R. Okay, I'm not gonna waste any more time checking it. And I'm gonna try to do as many as possible. I don't want this video to be long, so like I said, 20 minutes. I'll just cut it off, but I will try to do all of them. Pyranose, we're doing 6-member ring, adding the oxygen over here. And this one we're doing L, but we're gonna do it as D, and we're gonna do beta as D too. So everything will be as D, and then we'll mirror it at the end. So we've got our oxygen on the top, and then we have glucose, not to be confused with gulose. So we have 1 at the right, so it's down. On the left, up. Right, right. We know that this R configuration is going to be on the right side, so we can leave it like this, and this makes it D. So we have beta for up, and then our down, up, down, down. Okay, I know this doesn't face down, but it's on the right side, and it's R. Okay, and now I'm going to mirror it. And I see everything has changed. Did it mirror? Yeah. So let's see if this came out good. I'm always scared. Okay. Okay. And we see that this ends up alpha, and that's completely fine. That's what we want. because L is like the complete opposite of what we're doing. Okay, so I'm going to orient this so that I have it like this. And I see my methoxy group is down relative to the hydrogen, so I know we're going to have L. So I'm going to leave it like this, or I'm going to put L, and then I'm going to mirror it. Okay, so I've already seen that it's L, so now I can actually pay attention to what this is. So this oxygen faces down, so I'm going to put alpha dash L, and then I'm going to start reading the code. We have right, left, left, right. Right, left, left, right. That is galactose. Galactose. And then I always want to put galactose and leave it like that, but we have to remember when it's a ring to put either pyranose or furanose. So just to make sure, alpha, we have right because it's down, left because it's up, left because it's up, right because it's R. Right, left, left, right. Galactopyranose. Alpha L. Galactopyranose. There might be something wrong. I don't know. Okay. It does help, like I wish I had someone to do this with, because like sharing my screen or something, because it would help if someone was like, oh, you forgot to put the pyranose. All day yesterday I kept forgetting the simplest things like that, mostly. So all the ring ones I kept getting wrong. Okay, so I turned off my hydrogens and now I'm gonna look. I believe I already have this oriented the way I want, because we see that both our methoxy groups are on the left, and that's exactly what we want to see. And then it's connected here at the 4 position. So yeah, this is my first molecule that I'm going to take a look at. I'm going to add my hydrogens. Okay. So they're both 6-member rings. So again, this can be lactose or maltose, or is it maltose? Yeah. So I see this is facing down, so I'm going to put alpha. I see that my methoxy group is facing up, so I'm going to put D. And remember, it's methoxy only. Okay, now I'm going to read my code, and I've got right, left, right, right. I think that is glucose, right, left, right, right. Yes. Glucopyranose. Go to the front, and I see it's connected to the 1, 2, 3, 4 dash O. Okay. Okay, now I move on to this one, and I see it's connected at the alpha position as well. So I'll put alpha dash. I see the methoxy group on the left is facing up relative to the hydrogen, so I'm going to leave it like that. Let me make sure I put my dashes everywhere. Okay, now I'm going to start reading the code. So this is right, left, right, right. So I believe that is galactose. No. Right, left, right, right. Is that glucose again? Right, left, right, right. Yeah, so we have glucopyranosyl rex. Okay. I know double checking is important. I think it takes a long time to double check this huge molecule, but let me see. Alpha, this is right, left, right, 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 left, right, right. I kind of just want to leave it like this, do a double check on the spelling, glucopyranosyl, alpha D glucopyranose. And let me look at my paper and see if I have every component that I need. It looks like I do, so I'm going to leave it like this. It's so stressful. Okay. Okay, so I see it ends in pyranose, so I'm going to do my 6-member ring. I'm going to do my oxygen, and I'm going to add my hydrogens. I see it's L, but I'm going to be drawing the D version, and then I will go ahead and mirror it at the very end. So I've got my oxygens, and I see it's a beta, so I'll put it on top, and then I'll look at my ribose and start reading my code. I've got all of them down because they're all right, down, down, down. And let's count my oxygens just to make sure. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I actually have 5 carbons. 1, 2, 3, 4, 5. And my hydrogens. That's also one thing I forget because at some of them I add my hydrogens at 2 points, and I always forget the third one. Okay, so I have beta, and I've got all of them facing down because they're all on the right. And then lastly, I'm going to press mirror. Don't want to forget that. And I'm going to leave it like this and hope for the best. Okay, I'm trying to get through these last two so I can go to class. Okay, let's try to go fast. Hydrogen's off. Turn this, okay. Let me turn this around like that. Yeah. So I've got both my methoxy groups on the left. Let me move this down a little bit, and then we'll start doing, we got 6 member rings, so it could be lactose or maltose. I'll add my hydrogens, and I see that it is alpha D. So alpha because this oxygen is facing down, D because this methoxy group, remember only methoxy groups facing up towards relative to the hydrogen. And then I've got right, left, right, right, and I believe that is glucose. Yes, glucopyranose. Go for the front, and we've got 1, 2, 3, 4, 4-O, parentheses, we've got beta. Where is my, okay, there's my, over here is the methoxy group facing up relative to the hydrogen. Oops, not like that, okay. And then we have right, left, left, right. I believe that's galactose, right, left, left, right. Galactopyranosyl. So what is this? Maltose? No, this would be lactose. Okay, do one final look. So I'm just looking at, I have alpha, yes, alpha. I've got beta because this is on the top on this second molecule, which is why I put beta. I have right, left, left, right, so galactose. This one I have right, left, right, right, glucose. Both D configuration, galactopyranosyl, alpha D glucopyranose. It looks about right. Okay, I'm gonna leave it. The last ones are always the most stressful ones. I know you guys can attest to that. And this is gonna be like the hardest one, D-ribose. Watch, I'm definitely gonna get this wrong. So ribose, I got 1 carbon here, 1 carbon here. I'm gonna just do my chain. So I've got 1, 2, 3, 4, 5 carbons total. 1, 2, 3, 4, 5. Switch to hydrogen. Switch to oxygen. I got my double bonded oxygen up here. Oops, not like that. Single bonded oxygen. And then I'm going to add my hydrogens and arrange things so I can go ahead and then add my other stuff. So on these, I like to use the twist function. I've kind of gotten used to it a little bit, and it's been helpful to try to get everything, get everything in line. Sometimes it's a little difficult to use. Like right there, I can't. It's like, I don't know where it goes. Okay, let's... It wants to twist everywhere except for where I want it to twist. Come on, just twist. Maybe I keep... Okay, come on, come on. Okay. Okay, so starting from the top, so for my carbonyl group, because if you read it on the paper, we've got CHO on the top, and then I'll start adding my oxygens on the right, so we know ribose are all on the right for those three in the middle. I've got my oxygen. Okay. And I'm not going to leave it like this, like I've been doing. And then look, if you add another oxygen over here to this CH2, it's going to be wrong because we need that. Okay, don't forget to add your hydrogens at the end. And then always make sure to count your carbons and your oxygens, because if you have too many and you look at your paper, you have 6, that means you added 1 to this CH2 group, and you don't want to do that. You want to make sure to fix it. Okay, all I can do is hope at this point, and I'm kind of scared. Awesome. So I hope this helped. I'm sorry it was a little long, but I like to show you the whole lesson. Good luck. I do recommend printing all this out, writing on paper, so you don't forget, your right, left, right, all that stuff. But yeah, good luck.